So good morning, guys. You with me? Perfect. So I'm Jens, and I'm going to talk to you about storage. So this is going to be the hitchhiker's guide to all things storage. We don't have too much time, but I'm trying to pack it all into this remaining 25 minutes. Yeah, I do work for the company JSConfEU, very awesome company, and we open the mobile web. Yes, we do. So back to topic. Client-side persistent storage, which is kind of a long, awful term, but in case that you do not know what that means, this is about storing data inside of the browser, in opposition to the traditional approaches where we send data to the server and store it on the server side. We do store it on the client side, be it in a browser, a device, in your application. And I will give you a walkthrough through the current existing storage engines. Thanks a bunch. We were beginning in the past and move on to the future. I'll talk to you about existing frameworks that aid you and assist you in storing tasks. We'll have a look at mobile oddities, and we also, if time allows, we'll have a short glance on performance and security. And of course, there'll be IE bashing, but there will be acknowledgement of Microsoft's work in this field. So, why do we need client-side persistent storage? We need it for several things. On the one hand, we need it for web apps that have offline support, also known as work now, sync later. We're online most of the time, so but being offline capable becomes more and more important. We need it for apps that just need persistence, just for stuff like user preferences, application settings, and we need it as a controllable alternative to cache manifest. Cache manifest is great, it's HTML5, all the bus and everything, but it's not a storage engine, we cannot control it, cannot get data from it. And of course, we need it for all things mobile. If you're tethering on a train, you wouldn't want to pull the data over the wire over and over again if you do have the alternative to store it at the client side. Okay, let's start with the walkthrough. As I said, we will be beginning in the dark past and moving towards the bright future. And we have a more detailed look at two of the engines presented here, which are currently the best available engines. Okay, it all started with cookies, which are obviously the worst choice to store data. They have the lowest size limit of all storage engines. They are sent to the server on every request, also known as how to slow down your Ajax application. And they have basically no API. You need to write your own wrapper functions, or you rely on a framework that does the work for you. So I guess you know everything about cookies, so let's quickly move on to Microsoft's achievement, user-data behavior. Microsoft was the first to offer an alternative for persistent storage client-side, and it's been there since IE 5.5, and it still is there in current IEs. It's a nice key-value store, but it has some issues with size, because the available storage size depends on the zone that the current website is associated to, and that differs from 512K down to 64K. So 64K is what you can reliable work with. It's a special behavior that can be applied to HTML elements. And what's important and what's not in the MSDN article, it can be also applied to a link element and a style element, which can reside in the head and therefore are independent of DOM state. Next up is globalStorage, which was an early implementation of the early storage draft, which was then to become local storage. It was implemented by Mozilla in Firefox 2, which was in 2006, I guess. It's still there in Firefox, and as far as I know, it's going to stay inside of Firefox. But, well, yes, it's Firefox only, so that's the big drawback. But that was the first real key value store inside of a browser with a nice API having get and put methods. Next one is SQLite implementations. Well, it's a database. It has kind of broad support, as it's there in WebKit-based browsers and in Opera 10. So there are some browsers supporting SQLite. It has, compared to the other storage engine, a good size. I'll get more into detail later. Cons, yes, it's no key value store. It's a database. Most scenarios where we need client-side storage, we do not need a database, but we need a key value store. And another thing is that there is no specification on how the SQLite implementation should be implemented in the browser. Yeah, let's get some details here. Rule of thumb, SQLite reads pretty fast and writes annoyingly slow, especially on large amounts of data. Writing a chunk of 1 megabyte can take up to seconds, and on a mobile device can take half a minute. And another annoying thing is that Chrome has a limit on the single field size. No matter if you choose binary large object as column type, it still has a limit. Other browsers do not have that. Well, as I mentioned before, there's no real specification. I guess, well, most of them, if not all of the implementations are just third-party SQLite implementations just baked into the browser. Remember, if you're using SQLite, remember to use variable binding. Those question marks inside of your queries, they also work inside of the browser. A very annoying thing about SQLite implementations across all browsers is that they have the habit of sometimes failing silently, not storing your data, but not throwing an error, and not calling your error callbacks. So this makes SQLite pretty unreliable, and in my tests it happened over and over again. But check for worker support. This is there in Chrome Dev Channel, and I bet it's not there in Firefox 4, I guess, but I'm not sure. But this will come, and doing this work apart from the UI thread is definitely a good idea. Some more notes on size limits. That differs from browser to browser, but you can be assured that you've got 5 megabytes of data, which is a big deal for most scenarios. And on Safari and on Opera, you have up to unlimited storage, but that depends on user choice. User may reject your request for more storage, and well, then you don't have the amounts. But basically, technically, it could be unlimited on Safari and Opera. On Chrome, you could get unlimited storage for the Chrome web apps. There's a manifest, and you can request unlimited storage there. I don't know if this has landed yet, but it will, I guess, very soon. Opera is pretty cool in here. Opera shows, if you need more than 4 megabytes of data, it shows a pop-up box to the user with a drop-down, and it really has the word unlimited in there. So unlimited is, well, pretty cool. Okay, next up is local storage. First, I'm a bit biased here because I personally think that local storage is by far the best storage engine currently available. It's there in all current major browsers, even in IE8. So if you're building a modern web app, local storage is there for you. It has the perfect API because it's a plain key value store. It's got set item, get item methods, clear, and delete item. Basically, that's all. Well, there are some more properties, but it's a simple API. It's very cool to code with it. Local storage is still in draft status, but it's implemented across the browsers with the exact same API, so chances are this is not going to change. So the code you write for local storage will be usable in the future for a very, very long time. And again, also with local storage, if you use it, check for worker support. Also in Chrome Dev Channel, there's workers support for local storage, and I'm pretty sure it will get into other browsers as well, so that you can do your storage tasks outside of the main UI thread and keep things flowing. No cons, absolutely. Yeah, okay, maybe one thing, size again is an issue. Come on. Okay, gotta stop here. Remote isn't working. Size is kinda complicated, but still, I got some numbers for you. The spec recommends a size of 5 megabytes, but unfortunately Safari has a limit of 2 megabytes, which is, again, if you're storing application settings or JSON objects, maybe enough, but would have been nice if Safari had also 5 megabytes as the specification recommends it. There is no field size limit in local storage. You can store all the 2 megabytes or 5 megabytes in one field. There's these 200 megabytes in Firefox is for offline apps. Firefox determines offline apps by the protocol. If your application is run from file or from localhost, then you get 200 megabytes of data. But you should be careful writing 200 megabytes of data. This can get real slow. In Opera, we have the same dialog as we have it with SQLite databases. If you attempt to store more than 4 megabytes, the user gets a pop-up dialog shown with a drop-down box in it. And again, the user may select unlimited. So, well, Opera is pretty cool in there. You can have unlimited storage on the user. But, you know, better be careful. No user really wants that you store, I don't know, 1 gigabytes of data on his file system. Again, in Chrome web apps, you might get unlimited space too if you request it in the manifest file. Another very cool thing about local storage is the storage event, which is basically a great idea. The write operations are not do not have to be synchronous, they can be done asynchronous, and whenever a change of the storage object happens, a storage event should be fired. Well, and on the left, these are the top rows are the keys that should be in the event, and there's some other stuff noted in this table. Don't want to go into detail here, but some notes on it. First, Opera is the only browser that is really compliant to the spec. Again, Opera, big pro. This is really, really cool what they have been doing. It's local storage has been there, I guess, from Opera 10, so it's relatively fresh, but it's perfectly implemented. Another thing is cross-window messaging. The storage event is supposed to fire on every window that has the same storage object, which means basically the same domain, or in a concrete scenario, the same URL. But Safari and Chrome have a very odd behavior there because they fire the storage event in all other windows. So if you have 4 or 5 windows open, and inside of one window you modify the storage, then the event gets fired in all other windows, but not in that window that initially triggered the change of the storage object, which means that in one window environments, which happens most of the case, and which is the case on mobile devices, you get no storage event. Because there's no other window open that can catch the event. You need to work around. And another oddity is with IE8, because they don't have the event called storage, as it's recommended in the specification, but they have two events, on storage and on storage commit. I mean, why follow standards? On storage commit is fired when the local storage data is written to the disk, which is so low level that nobody really cares about. And in opposition to the documentation on MSDN, the on storage event is not fired on the window object, but it's fired on the document object. Took me a while to figure that out, why I wouldn't get any results from IE there. Yeah, that's local storage. Best storage engine currently available. Let's have a look into the future. There's IndexedDB, a new draft containing the object store, which has the great point that it can store objects. All other storage engines I've been mentioning can only store strings. So that you'd have to JSON stringify your data before you can store it. And Object Store will allow you to store JS objects directly. It will be both a key value engine and a real database, because you will have a synchronous API with get and put methods, and so you can use it as a key value store, but it will also have a database like access that you can query the store, you can create ranges, and you can iterate through result sets and move the cursor. So it tries to combine best of both worlds, and it's very, very promising. IndexedDB is probably our biggest hope to help us in our storage needs. Cons, well, it's not really there yet. You can play around with it. It's there in Firefox 4 and latest Minefield builds, and it's prefixed with a MOZ underscore prefix. But you can, Firefox Minefield only has the parts of the asynchronous implementation yet, but it's still, well, you can already play around with it. Next thing for the future will be the file API, because the file API from the specification will allow us to open through the browser a file on the user's file system, a new file where we can store data in it, which is very interesting, but it will only be a flat file thing. So if you really want it as a store, you'd have to do a lot of extra work to to manage your keys and everything. But it might be a good alternative if you try to store really large amounts of data. Say if you've got like some 100 images you want to store on the client side or anything, then this might be a good choice, because it, well, directly lives on the file system of the user. It's also there in Firefox and latest Minefields, but I got the feeling this will take a long time until we can really work with the file API. But file API is all the buzz, and let's hope that things are moving there. What I did not mention are plugin-based storage engines. They are, of course, plugin-based options, Flash, Gears, Air, Silverlight, I guess, but basically that's not what we are here for. We want plugin-independent client-side storage. So let's move on to the main question, which of course is, what engine for my project? Well, that on the one hand depends on your needs, of course, and on the other hand, it basically depends on the question if you know your target platform. Do you know what storage engines are available there? And if you're developing for the web, in most cases you just do not know. That means you have to do a multi-engine approach. You need to be prepared to deal with all engines that are out there. You got to search for the best available engine, and then just step down, step by step, until you find an available engine and use that one. This really sounds like pretty much work, especially if you want a unified API for your storage application. But rest assured, of course, there are frameworks that do the work for you, as others have already done the work of writing wrappers for the different engines so that you have the unified API, and these frameworks also do the sniffing, the feature detection of what engines are available in your current situation. In a desktop environment, this is not a problem. You have loads of memory, usually have a good internet connection, so you can just kick in another framework. Standalone frameworks are, for example, Launcher, Brian LaRue's project. It offers a document store, but you can also use it as a key value store. It's completely asynchronous because it also supports SQLite. It has local storage in it, userData, gears, cookies, and I'm not sure, maybe also global storage. Persist.js supports the same set of storage engines, also a standalone framework, and it's also asynchronous. And I bet there are more. In case you're already using a JS library, and then there might be, well, chances are that there's a storage wrapper inside of that library. As it is, for example, in JSConfEU. JSConfEU is synchronous, has a very nice API, currently supports global storage, gears, and Flash encrypted storage. And with 1.6, I hope there'll also be wrappers for local storage, userData, and cookies. And that, well, kind of depends on me if I finally commit them. YUI also has storage wrappers in there. At least in YUI 2 there was a storage plugin, and I strongly believe that in YUI 3 there are also wrappers. And, well, I guess, I don't know, other libraries will have wrappers for storage engines too. Okay, let's leave the sane world of desktop, where everything's easy, kind of predictable, and move on to mobile. Client-side storage is even more important in mobile development. And again, the first major question when you're trying to, or thinking about using storage for your mobile application is, do you know your target platform? And the good thing about mobile development is that in most cases you do know your target platform, because you're publishing your app or your web app via a store, so you at least know the operating system that your application is going to hit. And chances are that you are targeting a smartphone which has a good WebKit-based browser inside. And as you can see, on different operating systems you have, well, pretty cool storage options with SQLite and local storage. Even Bada has local storage in SQLite. WebOS 1.45 is supposed to have SQLite database according to their website, but in tests I found that it wasn't there. I don't know. Need to ask some Palm guys. On Android devices, because they're kind of Google phones, you also might have a Gears database built in, which is not, which cannot be disabled by the user. Size limits on mobile devices is again tricky. Basically, the limits are the same as you have them on the desktop environment, but mobile devices tend to be limited in storage by the device itself, so it may very well happen that you trigger a limitation from the device before you trigger it from the browser. So assume the same limits as on the desktop, but just be prepared that storage space will be more limited, not because of the browser, but just because of the device being full, because, I don't know, there's not much storage in there. The maximum of amount of data I ever managed to store on a mobile device was at least 10 megabytes on a milestone running Android 2.1, which is quite impressive for a mobile phone. So if you don't have a smartphone running a WebKit browser, you maybe have the widget namespace. And with that, you have access to the widget preference store. Widget preferences is also a nice key value store available in the widget namespace. The API is kind of odd because it has no delete method, and the methods are set preference for key and get preference for key. And it's pretty dangerous because it's recommended that devices using widget namespace may delete data of widgets if widgets that are more often opened require the space, then it can be that the stored data of your app just gets deleted by the device, which is not very nice. So, well, you have a store, but it's not really reliable. Probably you have an application built with a tool like PhoneGap, and then there are other options. You gotta be kind of creative, but there are options. In Android less than 2, there is an implementation of the internal SQLite database of Android exposed to the browser via PhoneGap. So on Android 1.6 devices, you might, using PhoneGap, you might have SQLite support, which you can open just via window.openDatabase as you would it with the normal built-in SQLite implementation. I also found some cookie size oddities. I managed to store 2 megabytes of data inside of a cookie in an Android 1.6 application, and it was not being sent to the server. And there are even more options that might be available. As I mentioned before, gears might be there. You might get access to the file system where you can store data, maybe larger amounts of data. And there's, for example, Couch for Android, which is also a nice option. Yeah, however, you just got to be creative, fool around with the device you're targeting and see if there are some crazy options that are not standards approach, but which are there anyhow. Jesus, time is running out. Okay, quick. Frameworks for that? No, not one. And you really wouldn't want to throw a full-sized, bloated framework on a phone. But very shortly, there'll be storage.js, which I initially wanted to release, but just didn't manage, which is especially targeted at embedded devices and which uses the embed.js approach. That means that you only deploy what you need, so that you have specific builds with the maximum or the smallest possible footprint for your target device. So it will be super tiny in size, and currently supports cookie, local storage, widget preference store, and Google Gears, and I might add SQLite to it. Performance. Well, in most cases, when we need client-side storage, we have no real choice, so performance doesn't really matter. We just cross our fingers and hope that it's fast enough. Thing to keep in mind is that reads are important than writes, because writes can be done in the background. But let's look at some numbers for local storage. Yeah, big deal in numbers. The only thing which is important here is that you see that Safari, these are operations per second. That you see that Safari has insane numbers. It's insanely fast, and that means when you look at the top row on Android 2.2, it beats most of the desktop browsers. So local storage on a mobile device is a really fast storage engine. It's really cool. And on a good smartphone, it's available for you. SQLite reads similarly fast, but far slower. Gotta hurry a bit. Security. Well, there's domain-based access restrictions for all storage engines mentioned here. Of course, it's not invulnerable to cross-site scripting attacks, but it's kind of secure, except for stuff like DNS spoofing, which then you're absolutely, you cannot do anything about it. The only thing that you can think about is have client-side encryption, like a Blowfish encrypted store, but that would make your store awfully slow. I did that, and it was like unusable slow because of encrypting large amounts of data is, slow. Okay, we made it. Number one, client-side storage is possible. It's also possible on mobile devices, and you never have to use cookies again to store application settings or anything you need to store persistently client-side. We have local storage, which is a perfect key value engine, and we can do a lot of stuff with it. And we also have SQLite, which is close, but also pretty cool. And future is bright. We can wait for IndexedDB's object store, which will be maybe the perfect storage solution that we've been looking for all the time. So it's doable, and it's getting better, and we can do it. Thank you very much. Thanks for listening. Thanks for having me.